In today's lesson, we're going to be looking at solving angles of right-angled triangles. So I just done a lesson on solving for lengths of right-angled triangles. I'll link that in the top right-hand corner if you missed it. And I want to extend that concept with solving for angles of right-angled triangles. So I'm going to do this using SOHCAHTOA method that we had discussed the last video. So how you approach this is pretty much how you've approached the other ones there. So in this case, we're not looking to solve for lengths of the legs of the triangle. We want to solve for the angles. So in this case here, let's suppose we want to solve for our angle here, theta. Directly opposite that angle, I'll label that opposite. Across from your 90 degrees is your hypotenuse, and your leftover is your adjacent. Now these measurements involve my opposite and my hypotenuse, and that's going to be my SOA or my sine. So in this case here, we've got here the sine of theta is going to equal my opposite over my hypotenuse. So notice I have no variable to solve for on the right hand side, which was normally the case in the previous examples. Now we're solving for a theta here. So to solve for theta, what you do is you take the sine inverse of both sides. And this sine inverse option is written as sine superscript -1 at the top. And whenever you apply the sine inverse to a function, if that function does have an inverse, these effectively cancel out and you're just left with theta. And now you're looking to punch in on your calculator the sine inverse of 10 over 15. If you ensure your calculator is in degree mode, the sine inverse of 10 over 15 is equal to 41.81 degrees. So that means the measure of this angle here is 41.81 degrees. So same idea here, we want to solve for the angles now, not solving for lengths, solving for angles. In this case here, this is the angle they want me to solve for, so directly opposite this, I'll label that my opposite. Across from my 90 is my hypotenuse, and the leftover is my adjacent. So in this case here, I'm involving my hypotenuse, and I'm involving my opposite. So this involves the O and the H. This is going to be a SO problem, right? You've got your SOHCAHTOA. So in this case here, we'll have the sine of theta equals my opposite, which is 10, over my hypotenuse, which is 20. Once again, apply the sine inverse on both sides of the equation. Your sine relation is invertible. And because it's an invertible function, these will cancel. This becomes theta equals the sine inverse of 10 over 20. And again, on your calculator, if you punch that in, you will get 30 degrees. Okay, let's try another example. So again, taking a look at our triangle here, this is the angle they want us to solve for. So directly opposite. This becomes my hypotenuse, and this becomes my adjacent. So this involves my opposite and my adjacent. So this is going to be a tan situation here. So this is going to be the tan of theta is my opposite over my adjacent. You can then take the tan inverse of both sides of the equation, in which case you get 20 over 30. And then you punch this in your calculator. So if I take a look at the tan inverse of 20 over 30, the tan inverse of 20 over 30 is approximately 33.7 degrees. Okay, let's try that again. Directly across is my opposite. Across from the 90 is my hypotenuse, and the leftover is my adjacent. So I'm looking to solve for the angle here, theta. I'm given the A and the H. This is going to be a cos question. So this will be the cos of theta equals my adjacent over my hypotenuse. And once again, I want to solve for theta. So we're going to go ahead and take the cos inverse of both sides of the equation. And your cosine function is invertible, so we're left with theta is equal to the cos inverse of 8 over 15, and that is approximately equal to 57.77 degrees. Okay, let's try one more here. So we got our angle here, theta. Let's label it. Just like always, this is my opposite. This is my hypotenuse. left over is my adjacent here. And this involves my adjacent and my hypotenuse. That's your A and the H. It's going to be cos. So we've got here cos of theta is 15 over 25. Therefore, theta is the cos inverse of 15 over 25, which is approximately equal to 53.13 degrees. Okay, that concludes the lesson for solving for angles of right-angled triangles. You notice it's just a basic extension to the lesson on solving for lengths. Once you understand the solving for lengths here, you just have the one extra step of taking the cos inverse, sine inverse, or the tan inverse of both sides to find the actual angle. Please make sure your calculator is in degrees as well. Keep in mind, if you want to match my answers here, I did all these in degree measure, so my calculator was labeled with a D, E, G. Usually that's in the top right-hand corner of your calculator under the mode setting. Thank you.